Well, good morning, everybody. I'm going to start off by looking at yesterday's satellite data just before the sun was setting. A couple of important features just I'm watching right now. First of all, we know that this very slow-moving cutoff low that's sitting underneath a broader ridge that's opened up across the kind of the southern Canadian prairie here is finally starting to move a bit farther to the east. And we saw overnight last night some of the heavier rains and some of the snow on the northern side of this move out of parts of New Mexico and Colorado through Texas, Oklahoma, and Kansas. And we're going to continue to watch the combination of this system plus a little shortwave that's to its north as all of this progresses toward the southeast. That's been a main story for this week. But I'm thinking about a couple of things today. One, I want to discuss the importance of the rain and snow that's coming down here to the southern plains in the longer context of things. Two, we do need to talk about the warmth that's coming in and what it might do to snow. Notice right now we have still some good snowpack in North Dakota, part of Minnesota, and southern Saskatchewan and Manitoba. That snow may have an expiration date on it here before we are able to get any more in the region. And then kind of the last thing is I want to just look again at kind of where I think this pattern is going to go as we watch, December evolve into January and February. So we're going to see what we expect to get out of all of this. Of course, along the way, there's a big jet extension, and we need to be talking about kind of what's going on in South America. So several tabs to roll through today, so let's get into it. We know that, in fact, I just started recording at 6 a.m. There we go. We got the newest data in for total precipitation. It's important to note that there are places in through parts of Texas, Oklahoma, and Kansas that did grab over 3 inches of rainfall. Some of this was snow, so this is liquid equivalent. And this is a tremendous amount of moisture for an area that desperately needs it, needs to store it, and continue to use it over the coming weeks and months. On the snowier side of this, now this is only through 7 p.m. last night, southern Colorado, northern New Mexico, pretty large area here picking up greater than 6 inches of snow, many places 8 to 12. And the models did a great job at honing in right in through this part of New Mexico at grabbing the biggest snows. But we do see some of this came out into Kansas and through the panhandles here. So overall, great job at the models trying to see how far to the east that snow is going to be able to make it. Now, I want to just skip ahead. I told you how important I'd said the rain and snow was, and I want to make a case for why that's my story. This is our current look at El Niño. All right. Now, we know that this El Niño has been competing against what we call the negative phase of the PDO right here. There's the negative phase of the PMM, and there's a lot of cold water down here in the southern hemisphere. So this has limited kind of the extent of this particular El Niño in terms of its how warm it could possibly get. You know this as well. We've seen that El Niño is likely at its plateau and is expected to fade through spring as we get all the way down here toward, summer. We could be talking about moving into weak La Niña territory. That forecast is also shared with the CFSV2 model. What I just showed you was the European. So here we are likely at peak and moving down. Most of the ensemble members are suggesting in the CFSV2, which is quite aggressive, like not just La Niña, weak La Niña, but I mean, this is just about as strong as the current El Niño on the opposite side. See that? So this could be a pretty rapid and important transition. Many of you probably saw this. It was released yesterday by the CPC through Columbia University. They've got the probabilities of the ENSO event here being still 100% through January, February, March. But then you start to see neutral conditions showing up as a higher probability by spring, April, May, June. And then by June, July, August, September, we now have equal chances at having neutral to La Niña conditions. And so this rapid deterioration, we just need to ask what that might mean and continue to kind of place some context in this as we go forward. So here's what I want to think about. Are the models really showing up with that colder water back in this area? And what could be some of the consequences? Well, they are. This is by next June. So just for reference, this is now. All right. And we just play this forward in the ECMWF and we start to see this showing up by June. Now remember, the ECMWF, is only going to run out 7 months. Some of the other models will run out longer than that, like the CFSV2 will go out 11 or 12 even. So if this continues to evolve, here's a couple things to watch. Watch the northern Pacific, like Gulf of Alaska ocean temperatures, and watch the Atlantic Ocean temperatures. If we're going to determine what this might do to the pattern across North America, our only indicator this far out, the only variable that shows significant, statistically significant subseasonal to seasonal correlation with weather patterns is going to be the ocean temperatures. And it's more complicated than just El Niño. So what if the North Atlantic stays warm? We keep a positive Atlantic meridional mode. but we have a negative Pacific meridional mode. That would be the near normal to cooler than normal water here. What about the Pacific decadal oscillation? Does it really get this warm? We've overstated the warmth here in the last several model runs, so I've got questions about that. But there's no doubt about it. I think right now there's strong evidence supported by history and supported by the models here that we'll crash this El Nino relatively quickly in the next 6 months. So it's not happening. I want to be very clear. Someone made it sound like it's happening in January. No. We're going to plateau with this current El Nino for a while. This is 6 months down the road that we're talking about this. So what do we know? All right. This is why I wanted to stress the importance of the moisture in this area and the moisture that's coming into the southeast in the coming weeks and months, and the moisture coming up the east coast in the next couple of weeks and beyond. Because May to September, on the years that follow an El Nino peaking in winter, which are these years right here, I'm only using years since 1960, they tend to be drier in those areas. Now, this is just looking back in history. It's not necessarily a forecast. I'm just saying, what are the tendencies? And that's what we're trying to examine here. So we were wetter in the Midwest, upper Midwest, northern plains. Parts of the Gulf Coast were wetter. Could this be because of the other major factor that shows up in August and September, which would be tropical systems? Yeah, you bet. I mean, if we end up getting warm Atlantic Ocean temperatures and an El Nino, we kind of take the shear out of this, and we can get systems that get into the Gulf of Mexico. So we have to be already talking about the potential for an active tropical cyclone season next year, above average, and many are already kind of discussing their forecasts. But my concern is simply this: in those June to Augusts of the years following a peaking El Nino, I don't like to see ridging over any part of the south. Now, the reason for this is our cotton belt has taken a pretty significant beating over the last few years with problems with drought. And if we keep a ridge of high pressure somewhere here, it may not necessarily sit right over Alabama or Georgia or this part of Tennessee, but if it meanders over toward Texas, or if it scoots farther east, what it does is it gives you that ring of fire around it. So the Midwest, upper Midwest, northern plains, it storms like mad. The Ohio River Valley tends to do okay as well. We tend to get flow coming through Ontario. Tend to even bring flow pretty decently up into the Canadian prairie. But we have to temper this with each one of these years had a different flavor, and we need to understand if that's going to be the case. Is it really going to sit here, or is it going to move around? And what might it do to any tropical system? Is it possible that it guides it south of Florida and maybe over towards Texas? I mean, history would kind of reveal that that's possibly the case. So this is just a look out there. So what I'm saying is, if there's going to be some sort of meandering southern tier of the United States ridge feature next year, its placement is going to be critical, and that's why I'm so happy we're getting moisture now here, and some that's going to be coming to the lower Mississippi River Valley soon, and what's coming up the East Coast very soon. So I just want to make a case for that. Now, currently, the models look something like this. Now, remember, the ECMWF only runs out to April, May, June. So June will be its last forecast month, and we're looking at all three of those months combined. And what I'm noticing is for that spring time frame, all right, we continue to see the kind of the remnant effect of El Nino, just promoting wetter conditions here, wetter conditions up the East Coast. But what starts to emerge is this. And kind of everywhere to the to the west of that line, I want to draw this a little bit better. Maybe let's do something like that. I start to get concerned about the redevelopment of drought conditions, an expansion of the rain shadow coming off the Rocky Mountains here. And we just don't want to, sorry, I can't seem to draw a good mountain this morning. There we go. I don't want to see that expansion happening back into the high plains next year. So we have to keep the risk on the table until we have evidence otherwise. So just to back this up, I'm going to go a little farther. May, June, July. This is the farthest out that the National Multimodel Ensemble goes. And can you start to see that same kind of issue happening here? So this is speculative. It's long range. It's just saying what if. And I want to point out something that we can start talking about now, just in case it becomes a bigger story as we go forward. All right? Okay, one last thing to do here. The El Nino we've got going on right now, as I said, is plateauing, but we have these other features to continue to consider. And one of those features is the Pacific decadal oscillation. Now, the big question I've got, in fact, let's just do this. I was doing this with my friend and colleague Matt Reardon, Andrew Pritchard yesterday, and we were saying, well, does the PDO stay negative? Because it is a decadal oscillation, meaning that it often takes about 5 years in its negative phase and then 5 years in its positive phase, and we're right now down here in this negative phase, which means should we expect over the next couple of years, kind of stay in that vicinity? And is that going to be the dominant force? Because if it is, and El Niño isn't going to be a major influencer, then we have to consider this. In fact, let's blow this up. So this is a correlation May to September with the Pacific decadal oscillation. So what do you need to see here? If the PDO is positive, it's wetter everywhere that you see the warmer colors. If the PDO is negative, it's drier everywhere that you see, let me rephrase that. If the PDO is positive, everywhere you see the cooler colors, it's drier. That makes sense? Warmer colors wetter, cooler colors drier if the PDO, the Pacific decadal oscillation, is positive. Right now, we are not positive. And is it possible to keep this sweeping around down here and stay negative and start to maybe make a change, but whatever? That would mean that everywhere that you see the positive colors would have the risk of being drier, and the negative colors would be the risk of being wetter. So you see, these are the competing factors right now that are making the longer term, risk package for 2024 in terms of precipitation very unclear. So what we need to watch, let's just come back to it again. Watch these ocean temperatures, watch these ocean temperatures, and watch these. Hurricane season, this affects the Pacific jet stream, this augments the Pacific jet stream. So those factors have to change. Now, I'll tell you this. If this goes cold and this stays warm, then the risk becomes drought conditions, plains, risk in the south, drier risk in the south, wetter chances for much of the Midwest, upper Midwest, and northern plains. So let's just leave it at that as we think about the bigger picture with all of this. Okay, where was I on my tabs? Let's come right here. What about where we're going? Well, certainly the month of December has been quite mild for much of the United States. It's been kind of most mild kind of north of that line. You can see these ranks are much lower than we've got down here south. And I was thinking about this with respect, let's shrink that back up, with respect to those, same El Niño Decembers. And it kind of follows closely with what history would align with, right? More mild north and cooler a bit to the south and west, and at times a little bit cooler in the south here. But then I think about this. Those Decembers, when there was an El Niño, did not have the size of the trough that we have in Alaska. We have a massive trough in Alaska right now. I mean, look at it. To blow that back up. This is what our December has been so far. And I've made a case that this is one of the things that has to really change in the upcoming weeks, and maybe even, I should say, months, in order for this pattern to evolve in a different way for North American temperatures and precipitation. The problem is, when I say months, is because we can get sometimes a pattern stuck for so long that it's more than 4 weeks that it sticks around. So that is, and I made a case for this last 2 weeks, that is my top of mind feature to be watching. Now, in those El Niño transition years, ones that plateaued in December, early January, and faded, what happened to January to March? Well, here's the years from 1960. We tended to shove all that warm air here farther east and start to kick it out. And a lot colder air began to arrive across North America. And this is the case I've made for the back half weighted winter. We are gonna have to be patient. If you want cold air, we're gonna have to be patient for that to get in here, and it won't probably be here till maybe mid-month of next month. Why do I think that? Well, those January to Februaries that had peaking then fading El Niño events, look where the ridge went. It went here. And that Gulf of Alaska trough kind of evolved out into the Bering Sea. And it set us up with a pattern that just started to crank. Now, we end up getting a pattern that cranks like this. We're going to be in business for a January, February timeframe that's going to be very active across North America. And anytime, if you're on the East Coast and watching this, anytime we see deep troughs rolling like this and ridging to the north, that tends to mean, pretty solid evidence of a lot of East Coast systems. So I kind of want to just frame everything else I want to share with you today around the evolution of these pieces. We've got the bigger picture things, PDO, El Nino. The short-term things are watch Alaska. Please watch Alaska. So here it is. And this is the new forecast for the beginning of January. Notice, right here in Alaska, the ridge that's plaguing us now seems to start to shift a bit. Where? Here. And what was the result? We get something like this with a little bit of higher heights here. Not a ridge, but higher heights, okay? So not as deep of a trough. And this could really start to set things off as we go forward. But it's not going to be this month. It's going to be the beginning of the new year, maybe the middle of the new year. So let's stitch all that together into a short-term forecast, because right now I'm still watching these features. We have a low that's going to try to cut itself off of California. That one is going to be adding some precip. I'll show you how much in a few moments. There's 1, 2, 3 short waves to be paying attention to, the deepest one being the farthest to the south, that are all going to advect east, increasing rainfall through the Midwest, upper Midwest, and parts of the northern plains, and then big time as we get into parts of the southeast and rolling up the east coast. This is what's setting up our pattern right now. There's a lot of amplitude to it. We know this is going to flatten out when the Pacific jet extends, so enjoy the amplitude while you've got it. What's happening in the high-res models is, as we play through today, you have the 2 northern waves, and here's the deeper one moving over parts of Oklahoma by this afternoon. As we play into this evening, we could get a switch over to some snow in parts of Minnesota, sneaking into parts of the Dakotas here. Some very light snow is possible. This is tonight. Then getting into tomorrow morning, this would be Saturday through mid-morning. Moisture is going to be moving through parts of Iowa, Missouri, Minnesota, Illinois, and straight down the Mississippi River. Now take a look at what's going to happen over the southeast as this all comes together. Remember, we were waiting to see if the northerly waves could help kick the southerly wave out. And the big question marks we had was, is this just a big Florida event with the risk of strong storms and flooding rains, which we've talked about, or is it going to get into Alabama and Georgia? Some of the new model runs are suggesting that the Alabama-Georgia solution, especially southeastern Alabama into Georgia, are probably the right solution. Take note of the rain that moves through the Midwest as well. This is desperately needed in this area. But what we've been doing all week is a 5-model comparison. Let's just do it again, okay? Here is the newest data from the WPC. Cutoff low, adding a lot to Northern California and possibly even getting some of that moisture into Southern California as we go forward. This is what's left over today. Then the system as it evolves, as you just saw, bringing the moisture in. Again, look, Alabama, Florida, Georgia, and then straight up the East Coast. You'll see that in a second. All of this is coming from the extra little effort these shortwaves are putting in here, but Canadian Prairie, much of the northern and western plains, high plains now are going to go back over drier after the system moves out. WPC, this is the 7-day European, very similar forecast, and this is the 7-day GFS. Let's toggle back and forth on these two maps which are on the same projection. So what would have been the wisest decision back on Monday? It would have been to blend the European and the GFS. You say, what do you mean? Well, remember, the GFS was super wet all the way into this area, right? Where is it now? It's found its way here. What was the European up to on Monday? It wasn't even doing this. It was taking this low way down here and then up the coast. So the wisest thing would have been to blend these models to get an idea on what this precipitation is going to be. Now remember, Louisiana and Texas are still our 2 states deepest in drought when you look back over the last several months, and Mississippi is now getting missed by this. To compare the models, just to show you there is still a more westward bias in the GFS being wetter than the European is. And if we look at the other 2 machine learning models, they've now come into a better agreement as well. This is the Fuxi model out 7 days, and this is the GraphCast. So very similar overall forecast between these 2 models. What this red shade represents, if we just click on the color bar down here, is somewhere between 50 and 100 millimeters of rain. 25 millimeters is roughly an inch. So this is pretty high probability of 2+ inches of moisture rolling up the East Coast. Again, why we need this. I made the case for the longer range here. So let's go into the models and just see how it evolves. And we're going to pick this up where the high-res NAM left off, which would be early Sunday morning, 12 a.m. Now you can still see the GFS brought the low farther to the north than the European did. But this is going to be windy, very wet, and there's severe weather risk in Florida. Now as the shortwave sneaks through the Midwest and combines with the low that's coming out of the southeast, we're going to watch the GFS be more progressive with its speed, pulling this through the Carolinas faster. European slower, very windy setup here. We're expecting winds, 30, 40 miles an hour sustained in and around that low pressure center. And then this rolls quickly to the north. Now, there's a lot of folks up the East Coast that I'm sure are looking at this going, what if? Just what if? Because had we had cold air in place, this would have been a massive nor'easter. We still call it a nor'easter. It just does not have the cold air to support big, big, big snows on the backside. So this is Monday morning, getting into Monday afternoon and evening. And you notice that during that time from over the weekend, the west begins to see the influence of the trough there, bringing in some of its moisture too. Now, the snowfall forecast is challenging here for the Appalachian Mountains coming off the Great Lakes. There's going to be some cold air, some strong winds, and so the models are trying to resolve what that could mean in terms of snow. I know it's only out Monday, and today's Friday, but I want you to watch this. Just go to agweather.com, ag-wx.com. You can look at all these maps and kind of continue to watch the evolution of this. Now, by Tuesday, that low is trying to leave, and high pressure settles into the southeast. And if that high pressure settles into the southeast, what does it do later in the week, next week, to help this low that's off the coast of California? See, it's still sitting there. As it starts to come in, what does it do in terms of opening the moisture back up? There's two things. I love seeing this. We need this in Arizona desperately. And if that high pressure cell can open up the Gulf again, what do we end up getting? Actually, the high's a little bit farther north in the GFS. We start to see this whole corridor light up again on like the 23rd, 24th time frame. Thing is, the temperature's going to be quite mild during that time. So we start to look at a couple of maps to help us understand this. This is the probability over the next 10 days of grabbing an inch of total precipitation, liquid equivalent, out of this forecast. Here's the chances of getting 2 inches. So again, it's that corridor up the East Coast, California, and then right where we're watching the moisture move through now. And then remember, there's a second kick about 8-9 days from now coming into this area too. On the drier side of this, Canadian Prairie, much of the northern plains, very dry. So are parts of the Rockies, and the interior here, kind of like the Columbia Basin into eastern Oregon. So that's really just showing us the other side of this. All right, from here, I want to show you what's setting up the pattern beyond that. This is this morning. Take a look at how cold the air is in parts of China and Russia, Mongolia. Russia's up here, excuse me. And that is what's creating the contrast needed, aided by the Himalayan mountains, to just rip off this extended jet. And here's the latest we've got on it. By Christmas Eve, okay, this is extension, still in the models, split ahead of it, which means, you know it, northwest flow here, but that's setting things up for week 2. And the models out in week 2 are looking something like this. Now, remember, we talked about it all week. Why did we watch the forecast continue to shove the heaviest moisture farther to the south? The reason is primarily the Gulf of Alaska trough. Now, let's paint a what-if scenario. What if the Gulf of Alaska trough fades and it's just not well represented? You take all of this and move it north, and it really lights up the United States, the whole of the U.S., into very active conditions. But that's still something we don't foresee happening. The Gulf of Alaska trough has pushed it south, and it's going to open up a system into the midsection of the country in week 2, but the flow is going to be coming in here into Southern California versus Oregon, Washington, at least based on latest evidence. And what's important about all of this is our current drought picture. You know, we've been looking all month long, not all month, all year long at soil moisture. So as you just take a look at the newest drought monitor released yesterday, this continues to show us how we needed that moisture that just came through here, how much more we need in this area, how the Midwest continues to stay drier as well. And as I said, that moisture coming into Arizona and New Mexico is critical as well with this jet extension. So there is very, very, important reasons to lose the ridge, lose the trough in Alaska in this pattern. All right, from here, I want to show you some snow. Just to make a point here, how much the West needs, we're only at about 20% of the average through December 14th in the Sierra Nevada. So normally they've picked up quite a bit. The West needs a lot of snow. We need to see quite a bit moving back into the Midwest to be, considered average. But we're having trouble, and the trouble is in the temperatures. Here's today's high temperatures compared to average, and we just walk through this week. There's tomorrow and Saturday and Sunday and Monday. It's just a repeat of this thing, except we finally get a little cooler air down south, but overall it just doesn't stick around for long. There's just no connection to deep Arctic air. So the next 5 days looks something like this compared to average. Day 5 through 10, which of course takes us up to Christmas, and then day 10 through 15. So remember, the takeaway here is that our most mild air is tucked away, somewhere here in the midsection of, oh, I've got those backwards. Forgive me. Do this. Take a look. I'm sorry. That's day 0 through 5. This is day 5 through 10. This one leads up to Christmas. So very mild here. Better chances of being colder up the East Coast. I mean, just very mild air for this time of year. And then this is day 10 through 15. This is your culprit. That's what you got to watch. If we start to see ridging here, then this is all gone. All this warmth is gone. But that may not happen for a while. All right, snow. This is the 10-day forecast, which leads up to Christmas Eve, snow depth. So if you're asking me where there's going to be a white Christmas, this is where the the European thinks there might be snow on the ground. The GFS is way more stingy. This is what it's got. So that's most of the U.S., save our mountains and possibly in North Dakota, maybe a couple of places around the Great Lakes interior of New England that have a chance at getting a white Christmas this year. Bigger picture things, though. Watch the Gulf of Alaska. Watch Alaska. Because if we can shake that trough, then it's going to really change up the precipitation patterns as we move through January. So let's go from the 25th of December to the 25th of January. And you do notice it's trying to open up more moisture to the central plains, keeping the west mostly wet, the southern U.S. wet. But this corridor right in through here, the mid-south to the Ohio River Valley is the area I'm going to have to watch carefully. All right, what also would help? If the MJO would start to make a move, come out of the Western Pacific, sweep back around here into phase 1, maybe get over into the Indian Ocean, we could really rock this pattern and get it going somewhere. But as it stands right now over the next couple of weeks, maybe some better rising motion in phase 1 at some point, but this is not the way to go. This isn't a strong signal, I guess is what I'm trying to say. This all affects South America as well. And I was looking this morning at the winds in South America, and we're still having that same problem. You can see the flow coming around this high here and just pushing it in straight from the east rather than from the northeast. But I want to make a point about what's going on in South America, and that is it is still raining. It's just well below averages. But this is the chance over the next 10 days of getting 2 inches. Now, if we could get 2 inches every 10 days across the Cerrado and getting up here to Mato Grosso, then this crop will be perfectly fine. I mean, it can use this in a big way, 2 inches. But just remember, that's about half of normal. They can get up to 4 inches a week on average here. So what is the probability of 2 inches? It's 50 to 80%, okay? The models still look like this when they show you the dryness, and we've talked about it all week, but I did get some questions yesterday that I want to clarify. It is drier, not dry, it's drier. So even when you see up here, which remember, this is the Amazon, okay? This is the growing areas down here. These areas are on average, they're an inch or 25 millimeters to some places approaching 2 inches drier than average. So I need you to know that this is drier, not dry. Meanwhile, Argentina is getting everything it needs. And look at that. That is breaking a drought, and that's huge. It is the same in the GFS. So I want to be just clear that when you're seeing these colors, this is off by a couple of inches compared to average, but there's probably still 1.5 inches to 2.5 inches of rain that could get into this area in the next 10 days. Actually, this isn't even a 10-day. That's a 16-day outlook. Sorry. This is a 2-week outlook. So same idea, though. There is moisture coming in here. It's just not close to average. Now, I do want to make a case, though. We have talked a lot about graphics like this that says over the last 2 months, it's been extremely dry. I've shown you that my analysis from the CPC being single-digit ranks up here and then up in the 40s down here, which means near record dryness, near record wettest since 1979. This is a data set from 1981, shows the same thing, and I'm going to back it up with another data set. This is from the ERA 5 data, which is from the European Center for Medium Range Weather Forecasting. October-November anomalies are only outpaced by, went past it, 1942. So this has been an extremely dry, start to the season. But the questions remain. Okay, let's just go ahead and have a look at it. Do we take the models at their word, which suggest, here we go, that we start to crack into this with some better moisture in January? Now, you know the models have been over forecasting this for a while. That's the question. Here it is again. If these rains return, this stops the bleeding on the crop. If they do not, it's at kind of a knife's edge right now, and it has the chance to fall off quickly. So these rains are going to be critical. The thing that baffles me, I mean, honestly, just baffles me, is this. We haven't looked at this in a while. I normally don't like to use NDVI data in the middle of the season because in Brazil, there's too many clouds. But right now, if you look at Mato Grosso, they are right at their climatological average on NDVI. The black line matches the red. If you add in Goiás and Minas Gerais, they're just a hair below. But if you keep adding the central Brazilian areas, which I think are the garden spot right now, so Sao Paulo and Mato Grosso do Sul, we're right on average. Toss in the southern areas, Santa Catarina with Paraná, and also Rio Grande do Sul. The whole country's sitting on its average. So I don't get it. I mean, it looks as though there's a lot of stress, but then the NDVI data says, nah, it's actually, things are looking about as green as they normally do. So what's been taken off of this crop? What's its vulnerability? I think you know the vulnerability. If the models are wrong and it trends drier, MJO doesn't do what it should do and move, then we have greater risk. But it's not a complete crop failure at this point, so we just need to make sure we kind of temper that narrative overall. Man, we've covered a lot today, but there's a lot on my mind, and I think we're just going to stop here, and I'll talk to you at the end of the weekend once we've seen where this system rolls up the East Coast and what it can do. So see you then. Thanks.